Hey there, Math 1. So in this particular video, we are going to be going over simplifying radicals. So just like whenever we were solving those quadratic formulas, there was a radical or the square root sign, and we're getting all types of crazy decimals. Well, this particular video is going to, and lesson today, is going to be walking you through how and why and where did all of those crazy decimals come from. So to start those off, we are going to be starting with a warm-up question. Complete the following questions while we wait for the others to join Zoom. So if you are joining our Zoom session, or if you're just watching the replay of the screencastify video as we go through this unit, I want you guys just kind of pause this video here and start making a list of these perfect squares. We are going to need them for today's lesson. So I kind of went ahead and got you guys started with 1 squared equals 1. The square root of 1 is 1. 2 squared is 2 times 2, which is 4. The square root of 4 is 2. So as you can see, these are inverse operations, opposite operations, just like adding, subtraction are inverse operations. Multiplication, division is inverse operations. Squaring and a square root is inverse operations. So I didn't have enough room on this screen to do so I went ahead and added a blank screen here. But we know that we have 1 squared is 1. The square root of 1 is equal to 1. 2 squared is 4, and the square root of 4 is equal to 2. 3 squared is 9. 3 times 3 is 9. The square root of 9 is 3. These are your inverse operations. 4 squared, 4 times 4 is 16. The square root of 16 is 4. 5 squared is 5 times 5, and that is 25. So the square root of 25 is 5. 6 squared is 36, so the square root of 36 is 6. 7 squared is equal to 49, because that's 7 times 7, and the square root of 49 is equal to 7. 8 squared is 64. The square root of 64 is equal to 8. 9 squared is 81, and the square root of 81 is equal to 9. 10 squared is equal to 100, and the square root of 100 is equal to 10. 11 squared is 121, and the square root of 121 is 11. 12 squared is 144, because it's 12 times 12, and the square root of 144 is equal to 12. Okay, pause the screen if you need to jot these down and even take a picture of the perfect squares that we're going to need to know for this lesson. Again, I just ran through 1 through 12 and then did the inverse operations to get the original number that we started with. Okay, so what does the square root of 25 mean? So yes, the square root of 25 is 5, but what does that mean? So taking it a step further, okay, we know that the square root of 25 has the value of 5. So that is the value, or that is the answer. But what does that particularly mean? That just means that you have 5 times 5, and that is equal to 25. And the square root of 25, again, is that inverse or opposite operation, okay? And then on this particular slide, they just typed in their responses. So warm-up question number 4, finding the side lengths of the area. So we know that they always use area as a way to describe the side lengths, of square roots, because of a square, or area of a square, I should say, because with a square, you have all sides are the same. So again, we're going to say this is a square. All sides are the same. We know that the length times width is equal to area, right? But if all sides are the same, I'm going to use the same variable. So I'm not going to use this one, although like x times x is still length times width, but I'm going to use the same variable because all sides are the same. So it has to be the same variable because it has to be the same number. So from our exponent laws, we know that we can write x times x as x squared now. So this particular problem is telling us that the area is 16, and so we need to find x. Okay, so just from the previous slide, we know that the inverse operations of squaring something is taking the square root of that. So 4 is an x value, and then we can always check, okay, 4 times 4 does happen to give us 16. So the area is 16. Okay, now the next one is going to take some critical thinking skills. Okay, so we have another square, and we know that the area, okay, the area of the square, the area of the square is equal to 10. Okay, now I don't recall 10 being one of our perfect squares, right? The area is 10, and that was not on our perfect square list. As I went through the perfect squares, and I keep writing in or on the screen, in our perfect squares, we had, let me use blue. Okay, so we had 1 squared, which is 1, 2 squared, which is 2. We had 3 squared, that gave us 9. And we had 4 squared, and that gave us 16. Okay, so somewhere in the middle here, okay, is going to be 10. Okay, now it is kind of closer, and I'm just using critical thinking skills to say that the square root of 10, okay, is going to be closer to this spot right here because 9 is closer to 10 than it is 16, okay? So the square root of 10 has to be 3 point something, okay? But I'm not sure what that exact value is. Now, yes, you can use the calculator, okay, but just using some critical thinking skills, it's somewhere in between 3 and 4. I'm going to say it's closer to 3 because 10 is closer to 9. Just critical thinking, some common sense. It's one. The difference is 1 from 9 to 10 versus 10 to 16, and that's 6. So in this lesson, we're going to be simplifying radicals or simplifying square roots, basically. So we're going to have some non-perfect squares that we're just going to have to simplify down, okay? So let's dive right into it, okay? So before we do that, I want you to understand, like, why are we doing this in this unit? Why are we doing it in this part of the unit? So we're going to quickly do a quadratic formula review. And we know that the quadratic formula is x equals negative b plus or minus radical sign, which is your square root sign, b squared minus 4, always 4, times a times c all over 2a. Okay, so a in this particular example is 1, b is 4, c is equal to negative 12. That sign must go with it. Okay, so I'm going to start plugging in numbers where they go. X is equal to negative b, so it's the opposite of positive 4, which is negative 4, plus or minus radical b squared minus 4 times a times c. So x is equal to negative 4 plus or minus 16, 4 times negative 4 times a negative 2 is positive 8. All over 2a. Divided by 2. Okay? So we have x is equal to negative 4 plus or minus 16 plus 8. All over 2. Okay, so within this section right here, we have the number 24. Okay. I wish I was teaching this lesson live because that number up there is not 2. C was most definitely a negative 12. Okay. Restart. And I'm too far in the video to hit the redo button. So minus 4 times a, which is 1, times c, which is negative 12. Okay. All over 2a, which is 2 times 1. Okay. So we have x is equal to negative 4 plus or minus radical b squared, which is 16, minus 4 times 1 times negative 12. Okay, so we're going to have negative 4 times negative 12. That number happens to be a positive 48, okay, all over 2a, which is 2, because 2 times 1 is 2. So x is equal to negative 4 plus or minus radical. If I take 16 plus 48, I get the number 64 divided by 2. Okay, so here in our quadratic formula is where my plus or minus comes into play. So I'm going to take negative 4 and I'm going to add the square root of 64 and divide that by 2. Or I'm going to take negative 4 minus the square root of 64 and divide that by 2. Okay, so I see right here that 64 is one of our perfect squares. So I can easily do that, and it's 8. So negative 4 plus 8 divided by 2, or negative 4 minus 8 divided by 2 to get those zeros, which our calculator does all that work for you, but I just wanted to take it all the way down and point out why today we are going through the square roots and simplifying those. Because, watch this, if I do my math correctly here on the next one, it's going to have an effect, okay? So you're going to see why simplifying radicals are happening, okay? So we have x is equal to negative b plus or minus radical b squared minus 4 times a times c all over 2 times 1. Okay, so let's take x is equal to negative 12 plus or minus 12 squared is 144. Okay, and then we have negative 4 times 1 times negative 4, which gives us a positive 16, all over 2. So x is equal to negative 12 plus or minus radical 144 plus 16. Okay, that gives us 160. So I see right there, okay, y'all, that is not a perfect square. Okay, so here is where simplifying those radicals or square roots is going to come into play, and why it is something that we are diving into during this section of our quadratic formula. So I'm going to go ahead and clear screen, and let's go on to the next one. So let's learn how to simplify. So there are two methods that you guys can work on for simplifying. One, this happens to be my favorite, and it's called prime factorization. So I'm going to take the 8 and I'm going to split it into 2 times 4. Okay, then we know 4 is 2 and 2. Now I can't factor this any further. So altogether I have the square root of 2 times 2 times 2. Okay, now I don't want to lose you, but this part is key. 2 times 2 happens to give us a perfect square, and that perfect square is the square root of 4, which is equal to 2. So I'm going to factor out a 2. So it looks like 2 times the square root of 2, because that one right there stays. And technically this right here, when I take it out, is the square root of 4, because 2 times 2 is 4. Okay, so let's go into the decimals calculator just to prove this. So we have the square root of 8, okay, and as you can see, we get a decimal. But if I do 2 times the square root of 2, I get the exact same thing. So it's just a way to simplify our radicals. Okay, now let's try it again here with 2. So I'm going to use prime factorization. I'm going to take 2, and that's times 6. 6 factors down to 2 times 3, and I can't factor down that 3 any further. So when I write this all underneath the radical sign, it's 2 times 2 times 3. So 2 times 2 times 3. And I see right here that 2 times 2 gives me a perfect square of 4. Okay, so it's technically the square root of 4, so I'm going to pop that on out, and I get the number 2. So what's left is 2 times the square root of 3. Okay, now let's test that one out. If I have the square root of 12, really, y'all? If I have the square root of 12, I get 3.464 with a whole bunch of numbers. That's irrational. Okay, now let's do 2 times the square root of 3. I get the exact same thing. Okay, so now let's learn the other method, okay, which really just takes it's technically the same thing, just some more critical thinking skills. So inside of your square root of 8, I know that there is the perfect square of square root of 4, okay? So square root of 4 is inside of here. And that just means that 2 is left over because 2 times 4 is 8. So the square root of 4 is 2, and this happens to stay in the inside. Okay, I can take the 12 and do the square root of 4 times 3. That perfect square is inside of there with multiplying. Now, a very common mistake, okay, is to split it up into 9 and 3, but that is adding, and that's not what works, okay? Multiplying works. Because whenever you're doing your square roots, it all talks about multiplying because the square root of 4 is technically 2 times 2, and then you have the 3 left over. So the square root of 4, if I take that out, is 2, and then I have the square root of 3 left. Again, that method is not particularly my favorite because I'm a visual person, so I want to factor those all the way down by doing prime factorization to really figure out what stays inside of that radical sign and what I'm allowed to take out. Okay, so let's try a couple others. Okay, the square root of 27. So again, my favorite method is prime factorization. So I'm going to break this all the way down into 2 times what? So if I do 27, okay, does 27, can I divide that evenly by 2? No, I can't. Okay, so let's try the square root. Let's try breaking it down into 3 because I know that 27 is 3 times 9. I can break 9 down into 3 times 3. So all of these are going to remain inside of my radical. So square root of 27 is really saying 3 times 3 times 3. Again, I'm using multiplication. And I can see that there's a perfect square right here. 3 times 3 is a perfect square because that's the square root of 9, which is 3. So I'm going to bring a 3 out, and I'm going to leave that remaining 3 inside. Okay, so the square root of 27 simplified is 3 times the square root of 3. Okay, I think you all got the hang of it now, but let's try some more. Okay, so let's take 24. Oh, that one factors down into 2, so it's 2 times 12, which factors down to 2 times 6, which factors down to 2 times 3. So underneath my radical sign, I'm going to have 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. Okay, I see a perfect square of 2 times 2. I know that is a square root of 4, and I can take a 2 out. So I have 2 with a radical of 2 times 3 left over. So the final form is 2 square root of 6. Okay, here is your final answer. Okay, so now let's take it a step further. The 3 is already outside, but we're just going to ignore that 3 just for a moment. Okay, for a moment only. Okay, it's going to come back to us. Only ignore it for a moment. Okay, I'm going to go ahead and break down 32 into 2 times 16, which then breaks down to 2 times 8, which breaks down to 2 times 4, which breaks down to 2 times 2. So 1, 2, 3, 4, 5. Okay, so again, I'm gonna ignore it, but I am gonna write it down. So that 3 is already on the outside there, okay? Now on the inside, How many twos did I say? 1, 2, 3, 4, 5. I have 1, 2, 3, 4, 5. Okay, now I need to search for those perfect squares. 2 times 2 gives me a square root of 4. 2 times 2 gives me a square root of 4. I know that one is times 2. Okay, square root of 4 is 2. Okay, so what's really happening here is I have 3. Oh man, that's supposed to be gray. Because it was originally there. There we go. 3 times 2 times 2. I was able to factor those out. There was the square roots of 4. And what's left? The square root of 2. Okay, now here's the tricky part, which is just really an extra step from the other ones. I need to multiply all of this. So 3 times 2 is 6, times 2 is 12. So my final answer is 12 times the square root of 2. Okay, now we can always check this again with the Desmos calculator. So I'm going to do 3 square root of 32. I'm going to get my answer. And then I got 12 times the square root of 2 left. Get my answer. They match. So I know that I simplified correctly. Again, if it's calculator active, more than welcome to use that part on the calculator. And then also for your practice assignment while you're learning the skill, please check your answers and then reach out to me if they're not matching up or if you have any questions. Okay, we have a couple more to try. These are our last 2. Okay, so I'm going to leave the 5 there. Okay, so again, I'm going to write the 5 in gray just so we can leave it there. We are going to need it, but I'm just going to ignore it just for a moment. Let's factor down that 40. So 40 is 2 times 20, which is 2 times 10, which is 2 times 5, and it can't go any further. Okay, so 1, 2, 3 2s times 5, and let's rewrite that. Okay, so let's put the 5 there, and the square root, 1, 2, 3, 3 2s, 1, 2, 3, and a 5. Okay, looking for those perfect squares, I see 2 times 2, which I know is technically the square root of 4, which is 2. So that 5 hangs out there on the outside. I'm factoring out a 2 because it's the square root of 4. And then on the inside, I have 2 times 5. Okay, so my final answer becomes 5 times 2, which is 10. And then on the inside, I have 2 times 5, which is 10. Okay, now as always, check your work in that Desmos calculator. So 5 times the square root of 40. 5 times the square root of 40. Get your answer, and let's make sure that 10 times the square root of 10 gives me the same thing. Bam, they match. We're on a roll. Okay, next we have the square root of 18. Let's factor that on down to 2 times 9. 9 becomes 3 times 3. Okay, so inside my square root, I have, or my radical sign, I have 2 times 3 times 3. Now, I can't pull out a square root of 4, but I do see 3 times 3, which I know is the square root of 9, which happens to be the number 3. So 3 square root of 2 happens to be my final answer. And again, I'm going to be checking that here in the Desmos calculator. So it was a square root of 18. Okay, and let's make sure that equals 3 times the square root of 2. Bam, they match. We're good to go. And again, I just went to Desmos.com and clicked on the scientific calculator here under the math tools where I was able to pull up this one. You are also more than welcome to go into your Google Classroom and click on the scientific calculator, which is located in your virtual learning resources. So today we are just simplifying our particular radicals. And please do not forget that, let me see if I can dive into it. Inside of your Google Classroom, if you are watching this during the 2020-2021 school year, inside of your Google Classroom, you are going to end up finding 2 assignments that are identical. The very first assignment is the teacher-made assignment, and it's going to ask you to show your work. So it is one that you can write on. You are simplifying right here by showing your work. Okay. And then number 4 is a Google form where you're going to be able to submit your answers and you will get your grade back. So again, if you need to redo this assignment or want your assignment reset, just make a private comment to me and I will reset them. But both of these are going to be counted for today's assignment. So showing your work, how are you simplifying your radicals? That's very important for whenever you get your score back so I can better assist you with this particular skill. So again, we're just simplifying our radicals today, which is another word for the square root sign. And as always, if you need me, I'm a private comment away on Google Classroom, or you can even shoot me an email. Best of luck to you.